You used to die from a paper cut. Not metaphorically. Literally. A tiny slice on your finger, a little dirt, and boom! You're gone in a week. Fever. Swelling. Delirium. Dead at 32. That was Tuesday. That was normal. That was just life for basically all of human history. And here's the wild part. We didn't know why. We had no idea. For thousands of years, the smartest people on the planet, doctors, philosophers, priests, looked at a person dying from infection and said, yeah, that's just the bad air doing that. Bad air. The actual medical term was miasma, which honestly sounds like a Pokemon move, but it was the foundation of medicine for over 2 millennia. So how did we go from it's the vibes of the air to mRNA vaccines in under 200 years? And more importantly, how does an ibuprofen pill, which you swallow, somehow know exactly where your knee hurts? How does your immune system remember a virus it hasn't seen in 30 years? And why every single time does Googling your symptoms end with you have 72 hours? That's what this video is. The entire history of medicine. Every major idea. Every world-changing discovery. Every moment where humanity looked at death and went, actually, no. We've got science. We're diving into all of it today, and trust me, you'll want to stay to see just how we survived our own medical history. If you love uncovering how we conquered the impossible, hit that subscribe button so you never miss another deep dive. Let's go back. Way back. We're talking 2600 BCE. Ancient Egypt. Guy named Imhotep, not the mummy guy, the real one, is writing what might be the first medical textbook. And honestly, some of it is remarkably smart. He talks about observing symptoms, examining wounds, describing treatments based on what he can actually see. That's empirical medicine. That's paying attention. For 2600 BCE, that is absolutely unhinged in the best way. But then he also recommends rubbing dead mice paste on bald heads. So, progress is non-linear. For most of ancient history, medicine was split between two things, the rational and the supernatural. You had priests saying, pray harder, the gods are angry, and you had proto-doctors saying, wait, let me actually look at the wound first. These two camps would fight for centuries. And for a long time, the priests were winning, because at least they gave people hope. Medicine, when it failed, and it failed constantly, just made you feel like you were dying and confused. Then comes Greece. 5th century BCE. Hippocrates shows up. And Hippocrates is kind of the reason we have a word for doctor that isn't also the word for wizard. He's the one who said firmly, loudly, look, disease is not punishment from the gods. Disease has a natural cause, and we can figure it out. That is a genuinely revolutionary idea. That might be the most important sentence in the history of medicine. Not because he was right about everything, he was very wrong about a lot, but because the direction he pointed in was correct. His big theory was called the 4 humors: blood, phlegm, yellow bile, black bile. Your body has 4 fluids, and when they're balanced, you're healthy. When they're off, sickness. And the solution? Get the bad stuff out. Too much blood? We'll take some. That's bloodletting. Which means for the next 2,000 years, the standard medical treatment for almost everything was opening a vein and hoping. Now, before you laugh too hard, stop and think about what it means to do medicine without microscopes. Without germ theory, without the ability to see what's actually happening inside a human body at the cellular level. You are doing medicine on vibes. You observe that sick people sometimes get better after purging. You don't know why. You build a theory around the pattern. It's wrong, but it's the best you can do with what you have. That is the story of early medicine. Smart people. Zero tools. Doing their absolute best. And still killing an uncomfortable number of patients. The big problem, the one thing that would unlock everything, is something nobody could see. Literally. It was too small. And until a Dutch lens grinder with too much time on his hands pointed a weird tube at a drop of pond water and went, "Oh, what is that?" Medicine was just guessing at shadows. Hold on. Because what he saw in that tube, that changes everything. The year is 1676. A guy named Antony van Leeuwenhoek. Say that name out loud, it's deeply satisfying, grinds his own lenses, builds a microscope so good it won't be matched for another century, and looks at literally everything he can find. Water. Scrapings from his own teeth. Blood. And what he sees is a world that nobody knew existed. Tiny creatures, moving, alive everywhere. He called them animalcules. We call them microorganisms. And they are, without exaggeration, the most important discovery in the history of medicine. But here's the thing. He sees them. He describes them. And then nothing happens. Not immediately. Because seeing tiny creatures and connecting them to disease requires a mental leap that nobody was ready to make. For almost 200 more years, doctors watched people die from infections and still blamed the miasma. The bad air. Even as cities built sewers and people mysteriously got healthier, coincidence, they said. Definitely the air. Has nothing to do with the poop in the drinking water. And then comes the moment that medicine actually wakes up. Two men. Same era. Different countries. Neither of them fully trusted at the time. Both of them right? First, Ignaz Semmelweis. 1840s Vienna. He's an obstetrician, a birth doctor, working in a hospital where women are dying at terrifying rates from childbed fever right after giving birth. He notices something. The ward run by doctors and medical students has a death rate of 10%. The ward run by midwives has a death rate of 1%. The only difference? The doctors are coming straight from performing autopsies. With their bare hands. And then delivering babies. Semmelweis says, "Wash your hands. Please. Just wash them." The medical establishment says, "Sir, this is a hospital. How dare you imply we are the problem?" He proves it. The data is undeniable. Hand washing drops the death rate by 90%. They ignore him anyway. He dies in a mental asylum at 47, ironically from an infection. The irony is so devastating, it should be illegal. Meanwhile, in France, Louis Pasteur is doing experiments with broth. Boiled broth in flasks, some open to air, some sealed, some with long curved necks that let air in but trap dust. The broth in sealed flasks and curved neck flasks stays clean. The open ones go bad. Conclusion: the thing making it spoil isn't air. It's particles in the air. Tiny organisms. Landing. Growing. Multiplying. Germ theory. The idea that specific microorganisms cause specific diseases. This is the foundation. This is the unlock. And shortly after, Robert Koch takes it further. He identifies specific bacteria causing specific diseases. Tuberculosis. Anthrax. Cholera. He builds the rules for proving it. Show me the germ in the sick animal. Grow it in a lab. Put it in a healthy animal. It gets sick. Same germ comes back. That's Koch's postulates. That's the scientific method applied directly to disease. That's medicine becoming real science. And now the escalator goes fast. Wilhelm Röntgen accidentally discovers X-rays while messing with a cathode tube. He takes an X-ray of his wife's hand. She looks at it and says, "I have seen my own death." Because seeing your skeleton while alive is a lot. But now doctors can see inside you without cutting you open. That is the kind of upgrade that changes everything. Alexander Fleming goes on vacation, forgets to clean his petri dishes, comes back to find a mold growing on his bacteria cultures. And the bacteria near the mold? Dead. Gone. Clean circle of nothing. A different person might have thrown it out. Fleming stares at it and thinks, wait, that mold is killing bacteria. What if we could use that mold is Penicillium notatum. That observation becomes penicillin, the first antibiotic. Wah. And this is the genuine awe moment, so stop scrolling, stop eating, just sit with this for 1 second. Before antibiotics, strep throat could kill you. Ear infections could kill you. A cut that got infected could kill you. Childbirth could kill you. Surgery was essentially a coin flip, not because of the surgery itself, but because of what happened after. Infection. The invisible enemy that nobody could stop. After penicillin, we could stop it. Not every time, not forever, and we'll get to why that matters. But for the first time in human history, doctors had a weapon that actually worked against bacteria. Between 1944 and 1972, global life expectancy jumped from around 40 to over 60 years. That is 20 years of extra life for millions of people, largely because of one mold on one dirty petri dish that one tired scientist didn't throw in the trash. The world changed because someone forgot to do the dishes. But, okay. Antibiotics kill bacteria. Great. What about viruses, N? Because those don't care about penicillin at all. And that question, how do you stop something that isn't even technically alive, is where medicine gets truly, deeply weird. Viruses are not like bacteria. Bacteria are living cells. They eat, they reproduce, they have their own machinery. You can attack that machinery with antibiotics. A virus is something else entirely. It's basically a set of instructions wrapped in a protein shell. It has one goal: get inside your cell, hijack your DNA copying equipment, and make 1 billion copies of itself. It doesn't eat. It doesn't breathe. It's technically not alive. It's a biological hacker running malicious code. So how do you fight that? And you use the most sophisticated defense system ever assembled by evolution. Your immune system. And understanding how your immune system works is maybe the most useful thing you'll learn today, because it explains everything: vaccines, autoimmune disease, allergies, and yes, why your immune system will absolutely destroy you from the inside if it gets confused. Here's how it works. Your body has 2 immune layers. First is the innate immune system, the bouncers. Fast, dumb, aggressive. Something foreign gets in? Destroy it. Don't ask questions. Cause inflammation. Bring in reinforcements. This is why you get a fever. Your body is literally overheating to make itself a hostile environment for the invader. It's chaos mode. It works, but it's blunt. The second layer is where it gets brilliant. The adaptive immune system. These are your T cells and B cells. They are slow to activate, takes a few days, but when they do, they are terrifyingly precise. B cells make antibodies, which are proteins shaped like little grabbing hooks, custom designed to fit one specific pathogen and nothing else. Like a key that only opens one door. They grab the invader, flag it, neutralize it. T cells hunt down your own infected cells and destroy them from the inside out. And here's the part that should genuinely stop you. After the infection is over, your body keeps some of those custom cells. Memory cells. Filed away. Waiting. If that exact same pathogen shows up again, even 30 years later, your body recognizes it instantly, deploys the antibodies in hours instead of days, and you don't even get sick. You fought the battle before you noticed the war. That is immunological memory. That is the biological mechanism behind every vaccine ever made. A vaccine is just a way of showing your immune system the threat without the threat actually hurting you. Your body learns. Your body remembers. Your body is doing something that the most advanced AI systems on the planet are still trying to replicate. Now, pharmacology, because we have to talk about ibuprofen. When you take ibuprofen, you swallow a pill. It dissolves, enters your bloodstream, and travels everywhere. Your liver, your lungs, your brain, your fingernails. So how does it know your knee hurts? It doesn't. That's the trick. It doesn't know. Ibuprofen is not a heat-seeking missile. It's a chemical that does one specific thing. It blocks an enzyme called COX-2. That enzyme is what your cells use to make prostaglandins the chemical messengers that signal inflammation and pain. Ibuprofen blocks that enzyme everywhere in your body simultaneously. Your knee hurts because your knee has the most inflammation, the most prostaglandins, the most pain signal. When ibuprofen blocks the COX-2 across your whole body, the effect is most noticeable where the signal was loudest. Your knee. The pill doesn't find the pain. It turns down the volume on pain everywhere, and your knee was the speaker blasting the loudest. This is pharmacology in its essence. Drugs don't aim. Drugs do chemistry. They interact with specific molecules, change specific reactions, and the effect shows up where those molecules are most active. Which is why every drug has side effects, because those molecules exist in other places too, doing other jobs. Ibuprofen blocks COX-2 in your stomach lining too, which is why you're not supposed to take it on an empty stomach. The drug is just doing its one job everywhere at once. And now, the thing about Googling symptoms. WebMD isn't wrong, exactly. It's just showing you every disease that could match your symptom list without context. A headache is a symptom of dehydration, tension, coffee withdrawal, high blood pressure, migraine, meningitis, and about 40 other things. WebMD shows you all of them, sorted roughly by how scary they are, because scary content keeps you on the page longer. Your brain fixates on the scariest option. This is not a medical phenomenon. This is an engagement algorithm. You're not dying. You probably need water. Which brings us all the way back to the beginning. You used to die from a paper cut, a scratch, a cough. And now we have germ theory, antibiotics, vaccines, surgery, imaging, immunotherapy, and mRNA technology that was developed and tested in under a year. The entire arc of medicine is humanity learning, slowly, and then suddenly, that the body is a machine. That disease has causes. That causes have solutions. And we are, genuinely, right now, in the most explosive era of medical discovery in history. Gene therapy is beginning to cure diseases we thought were permanent. CRISPR lets us edit DNA like a document. Artificial intelligence is diagnosing cancers earlier than any human doctor can. But here's the question nobody has answered yet. The one that keeps the best scientists on the planet up at night. Why do we age and... Not just how... We have theories, good ones, but why, at the fundamental biological level, did evolution produce a body that repairs itself so brilliantly for 40 years and then just slowly stops? Why did natural selection not produce a body that lives to 200 and... We can keep cells alive in a lab indefinitely. Some animals barely age at all. The mechanisms exist. So, what is the actual limit? Is there one end? We don't know. And that question, that single open door at the end of a 2,000-year corridor of discovery, might be the most important question medicine has ever asked. If we actually crack the code to biological immortality tomorrow, should we even use it? Or would curing aging be the ultimate curse for humanity? And leave your answer in the comments below, and make sure you're subscribed so you don't miss our next